I run into that problem sometimes too.
Yeah.
I forget to do it.
Did, yeah. So welcome everyone to, I think, the 5th installment of our Appalachian Natural History seminar series. Today we have the distinct pleasure of being joined by Rob Paratley. Rob is a scholar, a scientist, and a teacher based in the Department of Forestry and Natural Resources. He studied plant ecology and botany at Cornell. And at UK, he is the curator of the herbarium, which is where he is artistically joining us from the herbarium today. So maybe he'll say something about that. And Rob teaches a whole bunch of different classes related to plants and trees in the Department of Forestry and Natural Resources. And I had the distinct pleasure of seeing him regularly for 6 years while I was in grad school. So Rob, it's lovely to be back in the same virtual space as you.
Likewise.
We're looking forward to whatever you have to say.
Whatever we have to say. Well, good afternoon, everyone. Friday afternoon. Thank you, Kenton, for inviting me and introducing me. It's been fun to put this together, what we're about to talk about, and I hope it's kind of fun for you guys. Don't let the detail throw you off. Just enjoy the pictures and try to pick out the main points of what we're going to talk about. All right. But I guess before I begin, behind me is a plant collection, a natural history collection. It's pressed plants by past botanists and me as well, and they are arranged systematically like a library. And they are there for teaching purposes, which I use it all the time. And it's there for research and for anyone else who wants to look at plants and learn them. So that's the herbarium over here in Endemic. And I am going to, so I've got to share my screen now, which I'm going to do. Now you can all start to see this. And I've even learned how to make the controls go away, thanks to one of my students. All right, I'm done fumbling, so let's begin. Here's a picture of the Southern Mountains. This is the topic today, and I'm wondering how many of you have visited, hiked, camped, whatever, in Great Smoky Mountain National Park or Shenandoah National Park in Virginia, or driven along or hiked from the Blue Ridge Parkway in Western North Carolina. I wonder how many of you have done that. If you have done any of those things, you have spent good time, intimate time in the Southern Appalachian Mountains. And that's what we're going to talk about today. I'm going to try to tackle two things that you can see on the title there. I want to talk about species diversity, not from a biological inventory perspective. That's for another day and another time. But I want to raise the question and see if we can answer, to some extent, partially answer, the reason why the Southern Appalachian Mountains, just to the east of us, harbor one of the highest diversity deciduous temperate forests in the world. You have to go to China. There are little remnants, little pieces of Chinese temperate deciduous forests that are probably a little richer, species richer than ours, but there aren't many in the world that are. So let's go forth and enjoy our field trip, our virtual field trip to the forests of the Southern Appalachians. As you all know, don't need me to tell you that these are basically covered in forests dominated by leaf-losing flowering plant trees. And much of the eastern deciduous forest in the south looks like this. And much of the Southern Appalachians looks like this as well. Okay, here's a slide. Enjoy the diversity here. These are some of the tree genera. A genus is a group of closely related species. These are some of the typical genera that we see and think about when we think about the Appalachian forests. These are the important deciduous genera, and you can see, maybe you can see some of your favorites there. I didn't include them all because there are a lot of them, but these are some of the most important ones. If I had to give a shout out to one of them, one of these genera, I would tip my hat to oak up there, second at the top from the left. There are quite a few species of oak in the southern mountain forests, and they would probably have the most species of trees in that region. So the question I want to tackle in the first part of this talk is, what can we learn about the geography and the environment of the southern mountains that has lent itself to such high diversity? And again, let me say this again, so I don't want you to go off and say, the forests of the Appalachians are the most diverse forests in the world. That's not true. Tropical rainforests in all regions that have rainforests are much higher in species diversity. But what we're talking about here are temperate forests, forests that have 4 seasons, long winter, etc. Somebody wants to get in, and I'm going to let them in. Mary Reynolds is now in. And we're going to get rid of the controls again. So that's the question. And what these slides have, these last 2 slides have on them, are some of the rarer and more unusual plants. Let me go back one. That went away too fast. I want to highlight a word, a biogeography word called endemic. And it turns out that the Southern Appalachians have quite a few endemic plants and animals, for that matter. And endemic means an animal or a plant that has a restricted range. So in this case, something like the Carolina hemlock, its range is pretty much restricted to the southern mountains, to the east of us. Same with mountain silverbell and many, many others. And again, there are salamanders and other animals that are endemic to the Southern Appalachians. Here's another slide of some rarities that botanists kind of salivate over. They're endemic, and not only are they endemic, but 3 of these 4 are also quite rare and the subject of management, preservation. Okay, so the first thing, and we're just going to spend 1 slide on this, is that the climate of the southern mountains is, for all intents and purposes, pretty benign. It's got a long growing season. Summer temperatures are warm to hot, which is good for photosynthesis. And perhaps more importantly, the blue bar lines there, the precipitation is high and reliable throughout all of the year. There are, of course, small dry spells, but nothing too serious. So the overall picture here is a good one for growing a deciduous forest. Okay, the next thing we're going to mention is the pretty complex geology of the region. And I don't know if anyone has already talked to you folks about the geology. We're not going to talk about geology. We're just going to mention it in relation to the kind of environment that different rock outcrops, rock types can provide to forests, to plants. Okay, basically, the rocks that outcrop on the surface are the ones that help form the soils that the trees depend on. So we, of course, I use my cursor here, are in the Plateaus, Eastern Kentucky. Perhaps some of you are even from Eastern Kentucky. And there are plateaus that run up even into Pennsylvania and even into New York. And then there's the Ridge and Valley province, which is to the east of it. And you can see that in this, I think this is a computer generated topographic map. And in the upper left, let me get the cursor going here again. This is the rugged topography of the plateaus, of the Appalachian plateaus, like Eastern Kentucky. And then right next to it is the very different geological province and topography of the ridge and valley. And then there's also the other one that we're going to talk about. It's not on this page, is the higher mountains to the east of that, where the Smoky Mountains are and the Blue Ridge Mountains. That's where the high peaks of the Appalachians are. Okay, here's a picture of a cutaway of the geology of the plateaus to the left, the complex igneous and metamorphic geology of the mountains themselves proper, and then to the east of that is the Piedmont and the coastal plain that runs to the Atlantic Ocean. We're not going to talk about that at all. But the impression we get from this slide is that there's a lot going on geologically and that there are a lot of rock types here. And we'll just mention a few of them briefly. Okay. Now this slide harkens to the Plateaus, Eastern Kentucky, so regions that we're probably a little more familiar with. And the Plateaus are basically a layer cake of sedimentary rocks, usually with limestones lower down and sandstones higher up. The point of this slide is that depending on where you are in the Plateaus, you will see different rock types outcropping. And as a result of that, you will find very different soil types, of which we're just going to mention a couple right now. So think about soils. And of course, soils are terribly important for plant growth, for tree growth, both in terms of water and in terms of nutrients that plants need to grow. Nutrients like phosphorus and nitrogen and calcium and magnesium, things like that. Okay. Lower down in most of the plateaus and even in the ridge and valley, we usually find limestone. And we're not going to spend a lot of time on this, but all things being equal, a limestone derived soil is going to be very productive. It's going to have a lot of nutrients, especially calcium and magnesium, and sometimes phosphorus as well. And all else being equal, a limestone derived soil is going to produce a high diversity and productive forest. So where we see limestone outcrop, and we can see this even in Eastern Kentucky, some of the creek bottoms in Eastern Kentucky are underlain with limestone, and it usually provides for a very rich soil and a diverse forest. However, most of the Appalachians to the east of us are underlain by a complex of igneous and metamorphic rocks. Igneous rocks come from volcanic eruptions, and metamorphic rocks are transmuted by pressure and heat. The punchline here is that much of the mountains proper to the east of us are underlain with these kinds of rocks that create rocky soils in many cases. And they also create generally speaking, a poorer soil, a soil with fewer nutrients, and it may produce a less diverse and a less productive forest. Okay, here's another slide of what we mean by that. These are some of the shots from the slopes of the Appalachian Mountains, and you can see that they're pretty rocky in some cases. And the suite of tree species and plant species in general will be different on these acidic soils compared to, I'm going to go backwards, compared to these limestone soils, which are found sometimes in the lower valleys in the Appalachians. Okay, that's a simple introduction to how the complex geology matters and can create a different forest community from place to place. Now, let's look at something else. Here's a shot of the mountains proper. Okay, and we have some pretty, for the eastern United States, we have some pretty serious elevations. We have many ridge tops and mountain summits that top 5,000 and even 6,000 feet, which for the East is quite high. In fact, the highest peaks in the Eastern United States are in the Southern mountains. So why am I introducing this besides looking at pleasant and exciting scenery? The fact is that when you have mountains with serious elevation, and we really don't have this in Kentucky. Most of our ridge lines in Eastern Kentucky are not 5,000 and 6,000 feet. In fact, none of them are even close. Most of them are 2,000 feet. So in that case, we don't really get what I'm about to talk about, which is called an elevation gradient. Okay, let's take a look at that. The first thing that we can think about is the fact that if we had a weather station pretty high up on the summit of one of these southern mountains, say at 5,000 or 6,000 feet, that weather station would record a very different climate from the climate at a weather station at 2,000 feet or 1,500 feet elevation. And these two climate graphs show it. They show a couple of things. And the things I'm about to say will be pretty obvious to you, I think, but it's worth pointing them out. The higher mountain is on the higher mountain weather station is on the right here, and it has lower temperatures. That makes sense. You climb one of these mountains, and you'd better bring a sweater and a windbreaker, and maybe even a hat, because it gets kind of cold up near the tops of these. The other thing you can notice is that they get more precipitation. The higher elevations do. As air rises, it holds water vapor less, and that water vapor becomes clouds, and it becomes rain. Or look at the black here. In the colder months, it becomes snow. So the higher peaks, this is obvious, and I'm sure you all know it, the higher peaks are snowier, they're wetter, and they're cooler. So those two things create very different forest environments, comparing the tops of these mountains, these higher mountains, and the mid elevations and the lower elevations of these mountains. So let's take a look at what this looks like. Forgive my crude cartoon here, but the line in the back there is supposed to be a mountain slope from the lower valleys up through the tippy tops of the 5,000 or 6,000 foot mountain in the Southern Appalachians. So what we're going to do is look at how an elevation gradient plays out in a couple of ways. I've got the blue arrow there pointing to a conifer forest. And if you climb to the tops of the highest peaks in the Southern Appalachians, you will find a conifer forest that looks like this. And it's almost as if you had been transported to Quebec or the northern mountains of New England or New York State. Some of the species are slightly different, but the functioning of the forest and the kind of forest that it is, the way it looks, the way it even smells is very similar to a far north forest. And again, it depends on the peak, but if you get well above 5,000 feet, you're going to start to experience a completely different environment with a completely different assortment of trees and lower plants. Below that, as you're hiking, you may find also a colder environment. You'll find something that we call a northern hardwoods forest. So this is not a spruce fir forest at the tippy tops of these peaks, but high up, let's say above something like 3,600 feet elevation, up until you meet the conifers, you will find something, the blue arrow points to it, called a northern hardwood forest. And this is what some of them look like, and I picked out a couple of species there that are typical of these forests. So we're pretty high up in the mountains, and it's pretty cool, and they get some snow. And basically, instead of being transported to Quebec or Ontario or the northernmost mountains of New England, you're being transported to the upper tier of the United States, Michigan or upstate New York or Wisconsin, which has a lot of what we call northern hardwoods or beech, maple, yellow birch forests. So again, you climb up enough in these southern mountains, and you're going to get a forest that's very similar to this. Oh, again, almost completely different from the conifer forests above it, and very different from the mid-elevation forests below it. And here they are. Now, once we get to the lower and mid-elevations, what's coming into play here is not so much the elevation gradient and the more precipitation and the cooler temperatures and the more snow. That's not what's germane here. What's germane in these mid and lower elevation forests is something maybe a little more complicated, but we're going to try to go through it anyway. This has to do with topography itself, not so much elevation, but topography, the shape of the land, which way the slope is facing. Once we take this into account, here are a couple of pictures of the ruggedness of the Appalachians. The picture on the upper left is definitely taken in the Plateaus. It might even be Red River Gorge. I pulled it off of the internet. But the Plateaus would have rugged topography like this, which probably all or most of you are familiar with. And the higher mountains would also have tremendously rugged topography. And there are slopes facing in different directions. There are slopes that are very, very steep, others that are gentler. And then we look at here what slope aspect can do, okay? If you've done enough hiking, you probably have experienced this. If you are walking along a north-facing slope where the sun is indirect at best, right? You can see that in the pictures, right? The sun is on this side and you're hiking over on this side, it is going to be shadier. It is going to be cooler. The soils are going to stay more moist, and all else being equal, this forest facing north or northeast is going to be a little bit more northern in its biota, probably in terms of the animals as well. Turn around on the other side of that mountain or slope, and you're going to be facing the direct sun, and it's going to look more like this. It's going to be sunnier. The soil's going to dry out more, and it's going to have a more southern aspect to it, and the biota is going to be more southern. And you can experience this. And when you get an eye for it, you can certainly notice different plants and animals growing on different sides of these mountains. And the same is true to some extent for east and west slopes as well. The key thing there is the afternoon sun, which is the strongest. And on a west-facing slope, you're going to get that stronger, warmer, drying afternoon sun. Okay, now this is a little more complicated, but rugged topography, as we have in the Southern Appalachians, means that not only are slopes facing in different directions, but there are also different shapes to the topography. And believe me, this in some ways is almost the most important environmental factor helping us understand what kind of forest is going to be growing at mid or lower elevations, right? We're below the northern hardwood forest. We're below the conifer forests. We're down here in the mid and lower elevations. And knowing the shape of the topography can tell us a lot about the conditions under which trees will be growing. And we will see different communities in different places. Now, don't worry about all these H's and OCFs and all of that. Somebody mapped this out for Great Smoky Mountain National Park. And the purpose of this is not to get mired in the details, but to understand that a concave slope over here on the left, I somehow found a little cartoon of that, is going to be a slope, is going to be a slope in which water and the nutrients in that water are going to flow into the forest community and remain longer. Okay, we're not talking about a swamp. We're just talking about water percolating into the soil from adjacent places and upslope. And the concavity, picture a bowl, and picture how water and nutrients will kind of gather in that bowl. And this will make for an extremely productive, nutrient-rich, moist soil. And the trees will be extremely happy. And we'll see how that plays out. Now, the most picturesque and perhaps the most famous of the forest communities in the mid to lower elevations in the southern mountains is what we call the mixed mesophytic forest. And Lucy Braun, the plant ecologist from the 20th century, did a lot of work in the southern mountains and also in eastern Kentucky for that matter. And she's the one that came up with the concept of a mixed mesophytic forest. This is the forest that finds itself in the sweet spot in the topography, the bowl-shaped topography, the place where the nutrients and the water gather. And it makes for an extraordinarily productive forest, which means very large trees, very tall trees. And it also means high species diversity. The mixed mesophytic forests, or cove forests, as we call them in the southern mountains, cove forests, are the forests that are probably the most photogenic, the most spectacular, and they are the forests where one would go to look at spring wildflowers or ferns or other assortments of rich plant biota, and probably animals as well. Here's another couple of pictures of the mixed mesophytic forest. It's again in the spring, it's a glorious tapestry of ferns and wildflowers, and the trees again often top 120 feet tall or taller. And in fact, in the few uncut or so-called old growth mixed mesophytic forests, we can find enormous trees. The Great Smoky Mountains National Park has several stands like this. So this is the place to go. This is the place to camp or to hike in the southern mountains. But the southern mountains don't always look like this. In fact, the mixed mesophytic forests, these diverse, very productive forests, are actually, in terms of area, a fairly small percentage of the forests that we see in the mountains, okay? Another type of forest, it's also a concave topography, but it's a lot narrower and a lot shadier. And this picture is supposed to illustrate, it's probably one in here or perhaps one in here. And this map shows one of them. It's almost like a divot in the landscape. And there's probably a powerful stream that cut these ravines. And in these ravines, we have a different plant community that's different. It overlaps with the mixed mesophytic community, but it's a little different, and it's dominated by a conifer named eastern hemlock. And there are some other trees and shrubs that are indicative of these shady, cool, usually there's a rushing stream in the middle of them, ravine. There's an example of a plant that's pretty characteristic of these southern mountain ravines. So those are two places with concavities, but most of the southern mountain slopes, the mid slopes and the lower slopes, are, here's another slide of the understory of one of these ravines. This is actually from Red River Gorge, this picture with Rose Bay rhododendron in it. Now, this is what I was about to say. Most of the mountains are the slopes, the concavities, the convexities, excuse me. And here we find less productive forests, and we find less diverse forests, and we find little overlap in the plants from the mixed mesophytic forests. There really, there's not that much overlap in terms of the constituent plants here. And this is kind of what they look like. They are, and again, we have this in eastern Kentucky too. particularly in the mid slopes and the upper slopes of say, Red River Gorge. We have this there too. But these forests are also found throughout the southern mountains, and they're dominated by oaks and a few other dry site species and some understory dry site acidic species like mountain laurel here where my cursor is. So this is probably, these oak forests are probably the most widespread in the southern mountains. Here's another shot of these kinds of forests. This is a little more extreme. If the soil is a little drier and a little poorer, you often have pines mixing in with the oaks and other things. And here's a picture of an endemic southern mountain species. We won't find this species in Kentucky, the Table Mountain pine. Scarlet oak, we will see plenty of, but that's just an oak that's typical of these more extreme sites that you find on ridge tops and steep slopes and things like that. So I hope you enjoyed that tour. And it looks like I have a few minutes left, which I'm glad of, because I want to spend a little time not talking about space, not talking about geography so much, but I want to spend a few minutes talking about time. Okay, well, now when we're in the mountains, this is a picture of the high mountains in the Southern Appalachians, okay? When we're in the mountains, it's easy to think that these mountains, these forests in the mountains have been there since time immemorial for millions and millions of years. And in fact, some of the early plant ecologists thought this. And in fact, they invoked ancient times, millions of years old forests as a way of also explaining their high diversity. Unfortunately, a 20 million year old deciduous forest in the southern mountains is a fiction, and we no longer understand this to be true. We now know, and we all know, you all know this, that there have been probably 20 ice ages or glacial maxima. And while the continental glaciers never hit the Southern Appalachians per se, but the forest or the vegetation type in the Southern mountains probably didn't look anything like the forests that are there today. It was probably some kind of an open woodland and tundra that you might find in northern Canada. Okay, so what does that mean? So there's no deciduous forest here during these 20 glacial maxima, each one of which lasted for approximately 100,000 years. And the warming in between the glacial periods is actually much, much shorter, on the order of 10,000 years. So typically, North America for the last 2 or 3 million years looked more like this than what we see today. So what does that mean? Well, it means that the trees that we've been looking at and what we'd see in the Southern Appalachians weren't there during glacial maxima. Where were they? They were in various places. Different plants, different trees went to different places, and they basically spent the glacial maxima vacationing along the Gulf Coast or the very southern part of the Atlantic, in some of those places that I circled with the red ellipses there. And then as the climate warmed, they all migrated back from where they were. Their refugia is the word, the geographical word for that. And they migrated north at their own pace, and different trees migrated back in their own way and at their own pace. So I may want to make 2 points about this, besides the fact that we didn't always have these wonderful forests in the Southern mountains, that they are a recent development of the retreat of the glaciers. Okay, that's point number one. Point number two is the fact that these forests are only approximately 8,000 or 9,000 years old, and they reassembled themselves from disparate elements in the deep, deep South. Okay, how do we know this? we're not going to make a big point of this, but there have been a lot of carefully done studies of pollen cores from bogs and mucky wetlands in the southern mountains. And from these pollen cores, they do a census of the pollen. They can reconstruct the forest that probably shed the pollen into these wetlands and basins. And lo and behold, not surprisingly, approximately 10 to 12 or 13,000 years, there were the kinds of conifers that you would find in Canada today, in the red circle there. And then more recently, a deciduous forest, something like what we might find today, began to reassemble itself. Okay, now comes the punchline. Into this story that these pollen cores are telling us, into this story came Indigenous Americans probably through a gap in the continental glaciers as the glaciers were receding, possibly also in boats along the coast. But however they got here, and whenever they got here no less than 12 or 13,000 years ago. And they rapidly made their way across what's now the United States. And they were in the eastern United States probably 11 or 12,000 years ago. Now I'm going to tip my hat to Wynne Henderson, who talked to you a few weeks ago. And I'm just going to briefly revisit what she must have talked to you about in probably much more detail. The reason we're bringing it up here is that not only when we think about forests in eastern United States or anywhere else for that matter, we're not only thinking about soil, we're not only thinking about precipitation, we're not only thinking about summer temperatures and all of these other things and wind and that, we are also thinking about human beings and how human beings impacted the forests and even, dare I say it, managed the forests. So I've only got a couple of slides of this because I know you've already seen some of this, but I want you to think about indigenous human beings in our landscapes and in the Southern Appalachians in particular. They got here before, this is important, before the deciduous forest reassembled itself, okay? So the earliest Paleo-Indians, the big game hunters, the mastodon and woolly mammoth hunters, were here before the deciduous forest crawled back up from the Gulf and the southern Atlantic and reassembled itself. So people have been here ever since there's been a deciduous forest as we know it today. And as such, they have had more than a little impact on that forest, okay? And there's some items that I listed here on this particular slide. They were hunters, okay? Once the mastodons were gone, they broadened their palate and they were probably hunting and fishing all kinds of game animals. They used fire and they used it well and they used it extensively for many purposes, but certainly clearing the forest and thinning the forest. They did this. They girdled trees. They cleared brush. They favored the trees that gave them the walnuts and hickories and acorns that they ate. They were smart. They were managing their forests. Foresters today use the word silviculture to describe managing forests. And there's no question that the indigenous people of Eastern North America were managing their forests. No question about it. And then, of course, approximately 4,000 years ago, they began to cultivate plants and clear for fields of cultivated plants as well. This climaxed, and again, Henderson went over this much more detail, approximately 1,000 years ago. Maize-based agriculture had taken off in the eastern United States, and it led to denser populations. It lent itself to large chiefdoms and almost cities and seasonal camps in the high Appalachians, and even more active management of fire. So you can be sure, certainly by 1,000 years ago, Native peoples were having a large impact on the Southern Appalachians. Now we're going to wrap it up, and we're going to bring the Euro-Americans into it. And we're just going to do this very briefly. There's a picture in the upper left of a reconstruction of what the deciduous forest looked like. And pay no attention to the Western United States, but it was fairly contiguous deciduous forest in the Eastern United States, which may, at first glance, seem to contradict the last couple of 3 slides, where we're talking about indigenous management and clearing and agriculture. Why did the Euro-American settlers find so many forests intact with very large trees that they mostly cut down, as you'll see in the next slide? This is probably due, and Henderson probably talked about this too, it's probably due to the disruption and depopulation that Native peoples experienced once European diseases were introduced into the New World. So anyway, the settlers found many of these extensive forests with large, large trees. And in the Southern Apps, in the Southern Appalachians, by the late 1800s, 19th century, the timber companies had come to the Southern forests and cut them vigorously, extensively, and pretty thoroughly. By the 1920s, there wasn't much left. Now, people that settled in the Southern mountains had cut trees before that for fences, for construction, and for firewood. But the real rugged, extensive logging began in probably the 1880s or 1890s in the Southern mountains. And I just want to give a quick shout out to one tree that probably was more of an inducement to the timber companies getting into the Southern mountains than any other. And that tree was Eastern white pine. Yes, they cut everything, but this was the tree I think that they were most after. It was tall, it was large, the wood was versatile and useful. It grew very straight, and the timber people loved it. Okay, here's a couple of other slides of human impacts on the Southern mountains. It wasn't all logging. There are places in the Southern mountains, this is in the Smokies, this picture in the upper left, it's called Andrews Bald, and there are a bunch of balds in the high mountains. And you go to these places, and there should be a northern hardwood forest there, or there should be a conifer forest there, but instead there are these open meadow-like places. And what these places are, these balds, are artifacts of former settlement, pioneer settlement, and heavy, probably heavy sheep grazing. So the land use in the early 20th and late 19th century of the Southern mountains is still with us today. A couple of more impacts, and this is not happy talk, and then we're going to be done. You can ask me questions. Of course, coal mining came to the Southern mountains as well. Not the high Appalachians, fortunately, but the plateaus, like Eastern Kentucky. And in places, the impact was devastating and very, very serious, as you all know. The high mountains didn't experience this. Okay, 2 more impacts. In the early 20th century, a fungal disease was introduced from Eurasia, and it devastated the American chestnut, which was probably the most abundant and widespread tree in the Southern mountains. And every watershed in the Southern mountains lost pretty much all of its American chestnut. And it's a topic for another day, but this had a great impact on the Southern Appalachian people because the American chestnut was a tree of great economic importance and versatility. So there was that impact. And one more impact, actually two more impacts. I just added these slides about 20 minutes before the talk because I said, oh yeah, we have to say something about this too. Yes, going on right now, another introduced insect has devastated the eastern hemlock in many, many places in the southern mountains. So the southern ravines have taken a big hit in many places, and the hemlocks are skeletons. It's very, very sad, and lots of ecological impacts from that. In the highest mountains, not all is well there. In some of the places, the fir trees have been devastated by another introduced insect, the balsam woolly adelgid, also implicated possibly in the high elevation death of trees was acid rain. So it might have been a 1-2 punch in some of the mountains. Okay, so this is a lot of bad news. And this is the second to last slide, but I want to end on an uplifting note. Here's a picture I took in a nature preserve in Madison County, actually. It's called Anglin Falls. And what we find in Anglin Falls and many places is a beautiful, diverse second growth forest that had been cut. What's the punchline here? The punchline is that the southern forests have endured a number of impacts, some of them very, very serious, and they've lost tree species. But there's the word down there, there is tremendous resilience in the capacity of our southern forests to regroup and regenerate, and we can still enjoy them. So that's my show. I don't know how much time you've got left, but if there is time, I'm happy to chat with you and answer questions if I can. And I'm going to stop sharing, right? Isn't that what we do now? Yeah, we stop sharing, and now we can. And there's me again, and there's you. I don't know how much time you've got left. I think the class is over now, isn't it?
We'll take one question.
I blew it. I'm sorry.
No, that's great. PJ. Yeah, if you could just stand kind of, this is where the mic is, so stand kind of close to the mic. Okay.
Hey, I was just wondering, like, what we can expect to see in terms of plant diversity in Appalachia with like the changing climate. We might see like higher temperatures and differences in precipitation. So, what do you like expect to see?
Good question.
Yeah, I was expecting that good question, actually. So here's my thoughts on it. And again, nobody knows for sure. There are computer models that have suggested this and that. We're expecting more intense precipitation storms. We're expecting stronger and longer dry periods. I think what we're expecting is the shrinking of those beautiful, diverse cove forests and the expanding of the drier, less productive mixed oak and oak pine forests. I think we'd expect to see that. And also, as things warm up even more, the conifer forests at the tippy top of the tallest mountains could be endangered in the future. They could even disappear. So those are some sort of off the cuff possibilities for what might happen as the climate warms, which it is doing. Again, I had hoped to allow a few more minutes for questions, but if I don't have to go anywhere, if they do, they do. But if any of them want to stay for a few minutes, I'll be happy to chat or talk to them. I have nowhere to go now.
Let's thank our speaker. One more.
I'm yours.
Thank you so much. Everyone, please do feel free to stay. I'm going to stop the recording.